So everything in the platform starts with our secure edge technology. You'll see here on the top, today we have two form factors of that technology. We have the secure gateway edge, which is a small IoT gateway for unmanaged userless types of devices. And we have the secure endpoint edge, which is a small portable USB-C device that acts as a retransmission device on behalf of a laptop or a tablet. We then pair that with two additional components. We have a secure software-defined network overlay that allows all of the BIOS edges to communicate with each other, and thus the assets protected by the BIOS devices to be accessible through that overlay. And the third component is a central cloud managed control plane that allows any centralized administrator to control, provision, manage, see different policies, traffic routing rules, and configurations for their edge devices within their purview of their network. But I want to dig in here to what the secure edge is. The secure edge, for all intents and purposes, is the thing that's connected to the asset that is isolating it from the network and making it invisible to the rest of the network. That's kind of one of the things that people always ask us, oh, well, look, how do you make that asset invisible to the network? We make it invisible to the network because that asset is no longer connecting to the network physically with its networking card, right? BIOS is facilitating that communication connection to the network on behalf of the asset, and every piece of traffic that is touching either the network from the asset or touching the asset from the network has to go through the BIOS secure edge. BIOS is the gateway, it's the DNS, it's the DHCP, it's doing all of the NATing on behalf of the asset on any network that the edge is connected to. It's providing layers 1 through 5 of protection in the local network, meaning asset cloaking, route enforcement, attack and ransomware protection, attacks such as enumeration on the local network, discovery, spoofing, fingerprinting, throwing exploits, all of those types of lower layer network attacks typically used by bad actors or adversaries in a lateral movement ransomware type of attack are stopped at the BIOS edge. Okay. Then on top of that, you get the secure overlay, which only the edge and the approved resources on the asset can talk to that overlay. And we'll dig into that a bit more in a bit. I want to just share briefly the two main use cases for the product. So on a critical infrastructure side, you have this secure gateway edge, right? How the secure gateway edge gets deployed in the network is it is physically connected to, let's say, an industrial controller, a server, a camera, a switch, and then on the LAN side, the microsegment side, all of the assets connected to the secure edge become protected inside of the microsegment. On the outer side of the BIOS secure edge, it can connect to the network through a wire on an Ethernet basis, or it can connect as a client on that Wi-Fi. Okay, so in this specific use case, you can see that in the diagram on the right, we have a bunch of legacy controllers that have typically either been air-gapped because the owner of the network doesn't want those devices connected because they have baked-in vulnerabilities, or they have no good way to protect them, or they want to connect them, but they don't want to spend all the money required to actually run cabling to them because they want to maintain flexible manufacturing or production shop floor type of arrangement. And then on the networking side, they don't want to have to implement some sort of packet inspection or networking protection technology to actually say, okay, what traffic is originating from these devices? What devices do I have on my network, et cetera, et cetera. And so Byos can connect those controllers wirelessly to isolate them from the network while still providing access to them through the overlay. And so you can imagine, before, telemetry collection was a manual process where you'd walk up to the controller, it was offline, you'd plug in a USB stick, grab the data, walk it over to an engineering workstation, rinse and repeat, tens, 20s, hundreds of times. And now you can actually have all of your production assets connected to Byos and thus connected to the broader network, eliminate the internet exposure of those assets, and still maintain granular remote access and control and traffic to those assets without all of that exposure. So it's quite a powerful use case for secure gateway edge. On the secure endpoint edge, this is a use case for protecting critical high-level executives, remote employees, developers, third-party contractors working from home, where you might not own their laptop, but you want to own the communications of their devices when they are working. So have them plug in the Byos device, put resources behind the Byos secure overlay, and only allow access to those resources when the Byos endpoint edge is connected to the laptop. I think what's important on this case for sort of more defense-oriented customers and applications is that Byos meets sort of two main requirements driven through the NSA. You have the CSFC, Commercial Solutions for Classified, where Byos actually is a retransmission device on behalf of the asset that is providing hardware-based isolation. And on the second requirement here is Byos is an advanced maturity microsegmentation provider through the Zero Trust network and environment pillar, which is one of the 6 pillars of Zero Trust. And so it's a good product for a lot of those higher criticality and sensitivity type customers that you might find in governments, across the world. There's a number of other use cases that Byos works within. We have, securing telco networks when you have remote equipment across, across different sites. Our upcoming product will have an LTE capability so that a GSM module can be attached to it. And in addition to, both Ethernet and Wi-Fi, Byos will be compatible with cellular connections. Again, that's coming soon. And on a use case where you have, where you are an OEM and you're deploying your machines inside of other networks that you don't control, how do you have a way to isolate your own assets that you're protecting and managing inside of a network you don't own? Byos can be that sort of control point that says, okay, instead of me now having all of my own equipment attached to the network directly, and depending on that network owner to provide the protection, I can add Byos as an isolated layer of unified protection and control in front of my assets in that other network. So now that, the network, they'll do their thing, but I, as the OEM, can do my own protections when I get deployed in any other network that I shouldn't trust. And so I think that's a good hop over point now to Matias, where I think Matias is going to take us through a demo of the console. Does that sound good, Matias?
Sounds good, Ryan. So you've seen abstract representations of what the overlay looks like in the presentation that Ryan was just giving. Let me show you what it actually looks like in real life. This is an actual network map of a live, real world functioning BIOS overlay, which so happens to be the network that I'm connecting to, the BIOS network that I'm connecting to, where I have my personal devices, as well as my work devices, as well as my family devices, and also my IoT devices, but also the demo devices that I use for customer demos or a webinar like this one. I've got my entire network behind. My actual assets are behind several BIOS gateways, and the BIOS gateways are connecting to my home network in a flat connection with no complexity, with no expensive firewalls, with no expensive equipment to provide any sort of security, because BIOS is already taking care of that. This is the presentation that we were looking for, Ryan. It looks like this. And in abstract, and it looks like this in concrete. The concept of physical segments disappears. The concept of physical networks disappears. The concept of physical buildings or physical locations disappear. Once you get your assets connected to the BIOS overlay, then nothing else matters. I have multiple assets that have been, like Ryan was saying, automatically discovered by BIOS, because everything you plug into BIOS will be automatically discovered, and all the properties of those assets will be shown, will be presented by BIOS to the user. And everything that the asset is trying to do, such as open ports and services that they normally naturally have available, will not be open, of course, because BIOS is taking care of the security of them, but they will be presented here on the console, so you can start doing these access control rules that Ryan was talking about. And I'm going to show you how this looks in real life. So I have multiple assets that are connected to multiple gateways. The multiple gateways in different locations are connected to the overlay. And then access control is being established at the lowest layer possible, which is specific resources from any of the assets that you have connected to the network. And it looks like this. I've got, these are the edges. These are the actual gateways that I have connected to the overlay. I've got 2 endpoints, which are my travel USB devices that I keep with me at all times. I've got 2 of them on my BIOS pouch, and I use them on my iPad, on my MacBook, on my phone, etc. And I use them when I travel, so I can always be connected. The beauty of that is the portability that this gives you is not just the fact that you're going to be protected on uncontrolled, unregulated, unmanaged networks, such as a Starbucks, a hotel, etc. It's not just about getting the protection to and from that device, but also when you're connected to a BIOS device, you're automatically teletransported into that overlay. If you look at the map right here, you'll see that there's a zone right here called Matias. I'm going to zoom in. Matias, as you can see, Matias has access to multiple other assets on the network, and I'm going to go into details of what this actually means. But if you look into the Matias group, you'll see that there are 4 edges. I'm going to hover on it, and you're going to see that Matias Home, Matias E, Matias Travel 1 and 2 are all in the Matias, what we call a zone, which is kind of like a security zone, but it's a floating, roaming, scalable, invisible security zone. All of my devices that belong to that policy and zone will automatically have everything that has been allowed to that policy group and that security zone, regardless of where I'm coming from. Where the standard today is mostly based on source and destination, that's what you get with firewalls. If you're coming from that network to that network, then do this. If you have this IP address or that IP address, then do that. If you're coming from this switch port or VLAN port, then do this or this or this or that. None of that matters here at Byos. What is called the security posture of your assets actually travel and roam with the assets. When I'm here at home, I'm connected to the Wi-Fi. I have a Wi-Fi mesh system that provides Wi-Fi across my entire home where I'm working from today. And that mesh system is connected to this Byos gateway that you see right here, the Matias home. Now, when I'm connected to that Wi-Fi, through the Wi-Fi, I'm back into the microsegment that has been created by this gateway. And if I go to my Byos app and I go to settings and I go to Edge, you'll see that I'm connected to the Matias home, which puts me inside the microsegment created by this gateway, which gives me all the power and allowances that have been granted to this gateway via policies by the admin, just by me connecting to the network. But if I shut down my computer, I take my laptop or my iPad and I take this and I go to Starbucks across the street and I plug this to my computer, and then I connect this to the Starbucks Wi-Fi. It has its own Wi-Fi module, so it will connect to Wi-Fi for me. I won't be using my laptop's Wi-Fi. I will be using this. This will connect me to Starbucks, and it will put me, my laptop, inside that overlay as if I were in the Matias policy set, because I am. So it doesn't matter if I'm working from home on my gateway or if I'm working remotely with my endpoint, I will be part of the Matias policy group with the Matias zone allowances and everything I'm always able to do. I'm going to continue to be able to do so when I travel, regardless of country, location, even the device that I use. I can go to an Apple store or Best Buy, buy a brand new device with no software, no configuration, no preloading of anything, and I can plug in my endpoint to that laptop, that brand new laptop, and within 3-5 minutes tops, however it takes me to configure the new laptop, I will be right here. And I will automatically have access to all that at the same time that my laptop is invisible, at the same time that I'm protected from ransomware, that I'm protected from exfiltration, from open source intelligence, from discovery, from denial of service, et cetera, et cetera. All of that comes right out of the box. On top of that, my preferred access will also come right out of the box. So when I go to assets, all of these devices have been connected to the multiple gateways that I have in my house and home lab, which are these: Core, Demo Lab, IoT, etc. If I go to IoT, you'll see that I have a doorbell made by Logitech. That is my actual doorbell at my house. It is connected to Wi-Fi in my IoT network, but it is behind Byos. So the doorbell can still do its job, but it's also protected from my teenage daughter's cell phones, my guests' devices, anybody from the outside, anything that could happen to that doorbell that could be malicious, someone taking over that doorbell. They still won't be able to infiltrate into the rest of the network and start hitting my actually important assets. They want to take down my doorbell, be my guest. It has zero power. It has zero reach. Be my guest, be my friend. We'll talk about implications of that on the pivoting type of attack. Like, I'm attacking that so I can jump and start attacking other stuff, which is actually important. And that is actually something that Byos does take care of. I have an outdoor camera. I have an Apple HomePod. I have a smart oven, and I have smart thermostats. Hopefully, luckily, winter is gone here in Canada, so we don't need those anymore, but they're still connected to the network throughout the year. If I go to Matias, you saw those You saw the devices before. If I go to rest of the world, you'll see that I have another HomePod, other laptops. This is my wife and kids. Their iPhones and their tablets and their devices. And everything is segmented. I'm not in the same network as any of these devices because we're all under different BIOS gateways, but also different policies and different allowances applied to each one of them. So, like Ryan was saying, BIOS provides secure access control to and from assets. And for that to happen, for you to have the cleanest, most granular layer of access control, then what we do is we separate access controls into 3 layers. You as an admin get to configure access control in layers 2, 3, and 4 combined. It's not either or. For me to be able to, for instance, print on Ryan's computer, both Ryan's computer and myself will need to have enough permissions and allowances on the 3 layers to be able to establish the session. Like you saw here, we've got an industrial controller that has access to a server on a different building. You see the firewall perimeter behind it. They're in different buildings. The industrial controller can access the VMware server. If you look at the arrow is only pointing in the direction of that server, meaning that the VMware server cannot initiate a connection back to the industrial controller. It is a one-direction allowance, meaning that if anything happens to that VMware server, that it gets breached or something happens, it's compromised somehow, and then the attacker is trying to leave that asset and move towards other assets, that session will not happen. That attempt will fail. If the attacker tries to do discovery of all the entire physical network around it, it will not work. If the attacker tries to pivot or jump from this VMware server to other assets, it will not happen. But at the same time, the industrial controller will be able to do its job by communicating via FTP to the server. And this guy right here, the contractor MacBook, will be able to connect to the VMware server on HTTPS, but not on FTP. FTP has been allowed to the industrial controller, not to the contractor MacBook, and HTTPS has been allowed to the MacBook, but not the industrial controller. And that's how granular you can get. Single direction, single resource, single source, destination. But again, remember, if this contractor MacBook leaves the office and then takes their endpoint and connects from Starbucks or their parents' house, whatever, an airplane, they will be exactly where they were before. Their posture will remain and stay with them. So I have policies and zones. Every edge, let's go to Matias. Sorry, let's go to policies. Matias. The policy that Matias is in has these edges, like I was showing you before, and it has 227 blocked countries, meaning that geo-blocking of traffic has been enabled on this policy, saying that only specific countries are allowed in. Essentially, it's the only countries that have been allowed here are US, Canada, and I think 3 or 5 Western European countries. And the rest of the traffic is blocked. But remember, BIOS is decoupled from the asset, meaning that the policies are not applied at the asset layer. They are applied at the higher floating layer, which is BIOS. My computer has no idea what's going on. If you change a policy that applies to my computer via the edge that I'm connecting to, nothing will change on my computer's posture because there's no footprint of BIOS on my computer. There's no driver, there's no agent. Yes, there is an app, but the app is just an empty shell of a UX enhancer that speaks to an API that is running on my edge. Everything that this is showing is simply by connecting to APIs that are running on my device. What's a good API example, Ryan? API v1
Connection.
connection. No, not 61. Connection or connections? There you go. So I'm looking at broadcast ID of the Wi-Fi that is connected. Let me zoom in. Let me open Firefox. Firefox is a lot better at reading JSON APIs. There we go. A lot better. See, it's showing the gateway IP 2.1, local IP 277, public IP, secure lobby, which is the trademark of our overlay connection, 10.10.50. So if you go to the app and you check out the secure lobby, all this information, the app is just querying the API that is being provided by the device. Why this is important? Because the app has no security. The app has no protection. There's nothing critical that is happening on the app side. Meaning you can skip the app if you want, and it's not gonna make a difference in my security posture whatsoever. The app is just an easier way for me to manage my device. There's no protection happening on the app. That's what I'm trying to say. Everything is running on the device side. All the protection is happening on the device side. So because there's no driver, because there's no agent, there's no footprint of BIOS on my computer. If anything happens to my computer, and I mean anything malicious, there's no physical way for that rogue user, malware, etc., to pivot through BIOS, bypassing the restrictions of BIOS and getting to destination. Whereas when you're running a software solution like an XDR SASE, there is a footprint, there is a piece of software that the attacker can kill, that the attacker can modify, and then take advantage of. It has happened in the past. It happens normally. It's software. Whoever controls the computer controls the operating system and therefore controls the software. And the first thing that the attacker is going to do is to kill the protection mechanism of that asset. And that doesn't happen with BIOS because there's simply none. BIOS is just a network gateway. So when I block Algeria on this chat, my computer is not getting the blockage of Algeria. BIOS is. So then if my computer tries to talk to Algeria, I'm going to be talking to my gateway, which is the edge, and then the gateway is going to say no. And when BIOS says no, when BIOS denies something, the user doesn't get an access denied type of message. This is not happening on layer 7 saying access denied because there was a negotiation and you were denied access. When BIOS says no, it happens at such a lower layer that what you get as an end user is a request timeout, as if the cable were disconnected. You're getting zero intelligence over what's going on, how the system is reacting to your session, or what to do next, or anything at all. It's just, no, not going to happen. So when you try to do a discovery, when you try to reach out to other assets on the network, when you try to start moving towards other segments, what you get is a request timeout. When you're trying to talk to a secure lobby resource that you're not been allowed to talk to, you're going to get a request timeout. You're going to get a connection refused. You're going to get a nothing. And that's part of the beauty of how it's better to not being handled on the asset side and rather on the outside layer. So this is where it gets interesting. Every policy has a scenario. A scenario is a combination of allowances in terms of layer 2 communication to the outside that allow you to position your assets in different different postures, depending on the use case, the need to know, the need to use that you actually have. And we've got several. We've got clean internet to the clean access to the internet and clean outbound access to the LAN. Byos is never going to allow inbound access from the LAN, but depending on the scenario, you might want to have outbound access to local resources on the network outside of Byos. This is a use case that you would use when you're not so interested in overlay communications provided by Byos, because you have another solution like a SASE solution, and you just want to stack up solutions. I think we have a graphic for that somewhere here. Yeah, right here. On the use case that Ryan was mentioning before, you've got a person right here that has blocked internet access, but they have access to overlay. Then we've got a person that has all their traffic, internet and overlay routing through the overlay. And then this person right here that has direct access to internet. And they're using Zscaler, Cato, Perimeter 81, any other SASE provider. They still have the dotted blue line, which is management and control from Byos. And but that doesn't control, that doesn't redirect traffic of any kind. It's just the control, because you're still getting telemetry from those devices, from Byos devices. You're still getting configuration of policies, etc. But the traffic is being routed through any of our other SASE providers. And that is what this looks like. That's what you would use this scenario for. Kind of like an extension of this use case is scenario B, which has internet access, standard internet access, and inbound from the overlay, meaning that this is what you would have in the same scenario that you had before. You've got a person, a user, a machine that is using someone else's resources or services for internet protection, but you still want to have inbound access to their machines via the overlay, meaning that, for instance, you might want to do remote troubleshooting of that machine, whereas you would normally use the something like LogMeIn or any of those pieces of software, and you would use a third-party piece of software to connect remotely to that machine and provide troubleshooting resources, troubleshooting services. You can use the inbound access from the overlay and naturally use whatever tool was provided with the operating system, like RDP, SSH, VNC, etc., to connect remotely via Byos. That means that you're saving money on not having to buy LogMeIn, but you're also not using a third-party software that reroutes your traffic through their services just to get access to your troubleshooting user. And that's what you would use this. It's an enhancement of scenario A with an added solution to allow you to remote access your machines. Scenario C is an extension of scenario B, which allows you to have clean internet access to the outside, but bidirectional access to assets on the overlay. This is the scenario where you would have that user that we were talking about before, that they need access, that they have access protected, internet access protected by another solution, but you still want them to be able to connect to legacy devices. You still need them to connect to stationary devices. Anything that you need access to on the overlay on the other side to connect to non-internet resources, then you would use this scenario. This is one of my favorites. This is what we like to call the VPN killer use case. Byos as a solution is a VPN killer, but this is the one that is closest to the chest of 99% of the enterprise users out there, because enterprise users today use normal internet access, and they have a VPN to access resources on their network, whether that is a file server, print server, a web server, any internal resources that they have, and they split the communication that way. We've all seen several articles recently, very recently, about how VPNs are not secure and how everyone is trying to migrate away from VPNs. People have been trying to migrate away from VPNs for a decade, but it has since then, in the past couple of months, it has exacerbated The need has exacerbated to the sense that people are trying to move away from them immediately, like yesterday. The reason for that is VPN is outdated. VPNs are clunky. VPNs are insecure. VPNs are too broad. So when you have a VPN session on top of your internet session, then what's going to happen is that that VPN session is going to put your computer inside that network, kind of like this. Where is it? Here. You've got a network. You've got a VPN, either a client server VPN, like you would have on your computer running a piece of software, or you might have a site-to-site VPN. And what that does is that it puts assets on the VPN, and then any traffic to and from those networks goes through the VPN, including a potential attack. This is what Ryan was showing you before. Full access to the network via the VPN. When you have BIOS overlay traffic on top of your standard internet traffic, then you have access to the overlay on layer 2. But like I was saying, we still have 2 more layers to go, and we can do a lot of magic with those 2 layers. So this is your anywhere from your CEO, your engineers, any employee that connects remotely. This could be work from home kind of employees. This would be traveling salesmen, traveling technicians, anybody that is outside of the office at least a day a week should have they should have an endpoint, and they should be configured at least in this scenario. And by doing this, you automatically kill the need for a VPN for that user, which is a huge plus because VPNs are not good. This doesn't give you anything else other than letting the assets that are under this policy be present in the overlay. You still have more stuff to configure, and you still have a lot more to regulate on top of this. But this gets the asset one leg into the overlay. And the difference between B and C, B is only inbound, meaning that people can talk to me, and C is bidirectional, meaning that people can talk to me and I can talk to people on the overlay. Scenario D means that all internet traffic is routing through the overlay. Overlay traffic goes through the overlay, and internet traffic goes through the overlay. This is an automatic route all through BIOS scenario. You would use this in a scenario where you want to have all your information overlaid, not just the actual asset traffic, but also your YouTube videos. There are several scenarios in which you would want to do this, particularly the one where you want to have everything tunnelized and everything encrypted, even if it's harmless type of traffic. But also in certain scenarios where you simply cannot put software solutions on top of type of assets that simply cannot get that type of solution, then you would put scenario D and have the certainty that all traffic is being routed through an overlay. If those assets need to have internet access, which is not always the case, we'll talk about that in a sec, then this is the scenario that you should use, because at least all of the traffic is tunnelized outside of your network and then being handled by the overlay. This is the scenario that I use. This is the only scenario that I use, by the way. Even though C is my favorite, this one is a lot stronger. Then you've got no internet and full secure lobby routing. This is where it gets interesting. What we were talking about before is that the asset doesn't have to have the premise that all people say is, well, I have a data collection machine on building 1, and I have an industrial controller, an HVAC system, a server of any kind on building 2. That means that those assets need to be connected to the internet. I have remote access to my ICS systems. I have remote access to my data center. That means that they need to be internet facing, right? No, wrong. That assumption needs to be broken immediately. At least with BIOS, you don't need that anymore. The asset doesn't need access to the internet. BIOS needs access to the internet, but not the asset. So when you plug in an edge, apply it, policy E, and then plug in an asset to that edge, then the asset immediately will lose internet access, but it will still be able to communicate via the overlay because BIOS is letting them do that. This is what you should have between scenario E and scenario F, which is the same as E, but only inbound access from the overlay. This is the scenario that you should have on 99.999% of all your critical machines that don't really need internet access. And I'm talking critical infrastructure, I am talking finance, I'm talking defense, I'm talking manufacturing, I'm talking healthcare. David and Ryan help me out with industries that I'm forgetting. Any system that doesn't really need internet access for their need to know, and when you're asking that question, does it need internet access? Go back to what I was saying before. Does it need internet access, or does the conduit need internet access? BIOS is the conduit. Give BIOS internet access. Don't give the asset access. So in the use case that you were seeing before, that Ryan was talking about, the plant floor, right here, we've got industrial controllers, CNC machines, hydraulics that are connected to BIOS. They don't have internet access. They don't need it. The data collection machine right here, maybe it has because it has other uses, and that computer does need access to the internet. But these machines do not. So these machines are completely isolated on their microsegment. They cannot speak to other assets on the network. They cannot receive communication from other assets on the network. They are invisible to everyone else on the network like that. But at the same time, they are on scenario E or F, so they cannot even initiate a communication via the overlay. They can only receive, never initiate, only through the overlay, only from authorized entities, only on the resources that have been identified. I'm going to talk about these two in a sec because those are layer 3 and 4. But for all intents and purposes, anybody that you put on this session, regardless of what the asset is trying to do, it will not be able to talk to the internet, but it may still be able to talk to other assets on the overlay. This is extremely powerful.
I think that's a good point. I mean, Rockwell Automation came out with, advisory yesterday or a few days ago that basically said, a lot of our systems weren't intended to be connected to the internet, but we have systems that use the internet, so you should just disconnect all of these. Well, that's not really an appropriate sort of, mentality to have, right? Like you still want to be able to use all of your like you as a business have requirements that say, humans are accessing machines from, wherever it may be. Let's have both the access and the connectivity without any of that extra exposure. And that's exactly what these two routing scenarios are meant to have. We use our own product internally. We have internal systems in our engineering team that are using our product for different use cases, but with these routing scenarios, so that there's only one way in, and anything that originates from that specific machine can't get out. So it's super powerful.
When you look at those articles and you read those articles, Rockwell advises disconnecting. This is from what? Yesterday. Rockwell advises disconnecting internet-facing ICS devices. No, you don't have to disconnect them. Hold on. But that's part of the process that we're going through here with BIOS, that you have to start with those assumptions. I got to disconnect. I got to pull the plug. You don't need to pull the plug because you're going to lose productivity. You're going to lose telemetry access. You're going to lose access to other tools that are allowing you to enhance your operations, save money, increase efficiency, and you're going to kill those because you're plugging the cable. You're pulling cable. You don't need to. You can separate what the asset needs and what the asset is capable of doing, and its exposure from what it needs to do, from what its job is. You don't need to do that with BIOS. It is as simple as deploying this type of scenarios, E or F, on the edge you will still have full access. Let me show you what it looks like. I'm going to go back to layer 3 and 4 in a sec, but let me show you what it looks like. I'm going to go to, cancel that. I'm going to go to Demo Lab. Demo Lab has a scenario of F, no internet and only inbound secure lobby routing, right? That is the scenario. If I go to the Byos network, you'll see that Matias on layer 3 has outbound access to Demo Lab right here. Demo Lab has inbound from Matias. Matias has outbound to Demo Lab. This is what you configure really, really easily through the use of zones. So meaning that on layer 3, Matias has access to Demo Lab, but it's only in that direction. Demo Lab does not have access back to Matias. And if I go to assets and I filter by Demo Lab, you'll see that I have a printer, you have a web server, and I have a Linux multi. These are VMs because I have an ESX, one of the network interfaces of my ESX that is attached to a virtual switch that has these VMs is directly connected to a gateway, meaning that all those VMs are being fed networking by Byos, not the ESX. So this Linux machine has port 22 open. I have a port forward of 2200. I've got this web server has port 22 and 80. I'm going to use this for the demo. And then I've got a printer that has a bunch of ports, port 80, port 21, 23, 25. These are all very ugly ports that you are never going to want to allow on your network. FTP, Telnet, SMTP. Those are really, really ugly ports that the printer naturally, inherently has open because it needs them, it wants them open, so they're open. Some devices allow you to disconnect or shut down these services. Some assets don't. They either don't have the function to disable or they start to break down if you start disabling things like the printer that needs magenta to print in black. Why is that? I don't know. But the same thing applies to you want to use web management, you have to leave SMTP open. Why? Because. So you have immediately lost power of that, of your attack surface by doing that, because you have to let that open in order to do your job, but not with Byos. I can talk to Demo Lab on layer 3. I can talk to the overlay on layer 2, but I can only talk to the resources that have been allowed on that server. If I want to open up a terminal, and I want to do FTP. Do I have FTP? No. If I want to do, well, actually, let's do this. I'm going to shut down port 80. Port 80 is enabled. I'm going to disable it. It's disabled. And now I'm going to go to the IP address 10.10.41. It's not going to work. The channel has been destroyed. Even though I have access on layer 2, I have access on layer 3. I don't have access on layer 4, so I'm not going to be able to access that machine. I can still, probably can still ping it. Yeah, I can still ping it. I have access to it on layer 3, but not on layer 4. The moment I re-enable port 80 on that printer, now policies are being pushed, everything is being reconfigured on the BIOS side. I hit refresh, and now I can access the web portal of that printer. Nothing changed on that printer. Not a single config was applied on the printer that changed its own state. Port 80 has been open all along. So if I'm a user and I need to configure this, let me shut down port 9100 so I can complete the demo. I'm going to go to my printer settings. Printers. There you go. So I can access the web management. Let's say that I'm an admin. I just bought this printer, whatever. I'm going to plug it into the network. BIOS automatically discovered all these ports. I'm going to configure everything I need to configure on the network. And then what I'm going to do is I'm going to get it ready for users to be able to use it. So what I'm going to do is I'm going to shut down port 80 and verify that it no longer works. See that it's stuck there. I'm going to shut this down, and then I'm going to go and verify that the user cannot access that printer. I'm going to add that printer, 10.10.41, jet direct, which is the protocol that we're going to use. I'm going to add it, and it's going to fail. I'm going to leave this message right here. Now I'm the admin. Again, this is an asset that has been deployed. This could be overseas. It doesn't matter. Physical limitations are off. I'm working from home, but I could be, at HQ, or I could be in an oil rig, or I could be at home managing an asset in an oil rig in the middle of the ocean. It does not matter. Or deployed user or deployed machine of any kind. I'm going to enable this port right here via BIOS. And then I'm going to hit continue. And then I'm going to go back to this. And now it's added. At the same time that if I try to access the web portal, 10.10.41, it's still not going to work because I, as an admin, did my job. I configure the printer. That port does not need to be open any longer. That's it. Now the printer is only enabled on a tiny speck of my entire network, open to a tiny speck of people, only to the people that have outbound access to the overlay, and only from the people that have access to Demo Lab on layer 3, meaning in this scenario, only Matias, but also only to that printer on that very unique service that the printer has, which is port 9100 Demo Lab. Only 9100 and nothing else. So instead of having the printer enabled and then you connecting via VPN and having access to that network, you have access to a tiny microsegment, to a tiny asset, to a tiny resource from a tiny zone, and that's all you get.
Yeah, I think that's important. This is a very simple example with a printer that Matias has in his house. But, we've talked to, say, fast food franchise owners who have check printers in their corporate premises that, rogue users, whether intentional or unintentional, have actually access to print checks, right? The paper that comes out of there is a check that can be cashed. And so these are sort of simple examples that illustrate the real world sort of power of this, where you want to allow printing, but you don't actually want to allow access to that printer, right? And so if you have different BIOS edges and thus users in different zones, you can lock things down as you need without adding overly permissive access across a network per se. Gives you lots of flexibility.
Correct. If I go to this, I'm going to emulate a terminal session from any other type of machine. I'm going to go to this multi-machine right here. I'm going to go to Linux web server. I've got port 22, port 80. I'm going to open port 22. Before that, I'm going to try to SSH into that machine. SSH BIOS at 10.10.41. Not going to work. The moment I enable port 22, it should work. I'm going to get the fingerprint error. There we go. Fingerprint, yes. Password. And now I'm inside that machine. If I type the password correctly, nope. There we go. So this is a web server that is a VM that is going through the ESX that is connected physically to my gateway that is in the overlay. It is in the Demo Lab policy. If you remember, Demo Lab has only inbound access from the overlay. It does not have outbound access to the overlay. It does not have access to the internet. So if I go to this machine and I try to go out to the internet, if I do ping google.com, it will not have access to the internet, even though I have full access to that machine. Now, remember, this is a vanilla virtual machine. It could be configured as a vanilla asset. There's no tweaking here. There's no configuration being pushed to this device, meaning that if someone actually has access to that machine and they try to bypass this and try to exfiltrate information, they try to establish a back channel to, a bad country or a bad, resource, this session will not happen because the asset does not have internet access, because it's being controlled by a higher power that it's just simply saying no. If I'm an attacker and somehow I gain access to this machine and I have a root session, a God mode session on this machine, and I try to reconfigure this machine so that I would have access to the outside, there's physically no way for that to happen in a BIOS-enabled environment, no matter how much power I have over this machine. This is important when you're thinking about the scenario that we were talking about before, where what was the article that we were talking about before this morning, David? Chinese backdoors on U.S. cranes. Chinese backdoors, U.S. cranes. Chinese spy cranes in U.S. shipping ports. They have backdoors that have been running on those cranes for so long, backdooring information to China, and also allowing them to remotely access those machines and pivot from those U.S. cranes from the ports network into whatever U.S. infrastructure that those networks had access to.
The past 6 years. Yeah. The past 6 years. Yep.
6 years. So all of that immediately dies. That attack vector, that risk immediately dies the moment you deploy BIOS. But the most important part is that BIOS doesn't only help you solve future problems. It can also help you solve problems that you had before deploying BIOS. If the U.S. Port Authority would deploy BIOS right now, instead of replacing the cranes, they would spend 0.1% of the budget needed to replace the cranes. They would deploy BIOS today. Those backdoors would immediately be neutralized. Even though they're still there, even though the cranes are still infected, they would have zero power to execute.
Within our resources, everybody on the call here, within our resources on our website, we do have a white paper on dormant malware. So you can go in and have a look at that white paper. If you want to investigate further, we can always have another call and talk about that. But yeah, it's really important. Eliminating persistence that you don't even know that it exists in your infrastructure is what that whole conversation would entail. Over.
Yes, and the beautiful part about stacking up permissions is that if I do this and I exit the session, and even though the port is still open, even though Matias still has access to this on layer 3, if I go to this policy and I go to demo lab and I go to external network and I change scenario F to no traffic on layer 2, I'm removing that edge from the overlay completely. And I click save. I'm going to hit save. It's going to push, reconfigure, etc., etc. Once it's pushed, if I now do this, traffic is dead. Traffic is gone forever. Even though the port's open on the overlay and my access on layer 3 is still there. The asset is no longer in the overlay. It does not exist. The cable was disconnected just to time out. All I got to do to bring it back is go back to the external, bring it back to scenario F, click save. Again, everything is pushed, everything is configured, blah, blah, blah. Everything is reported back to BIOS. And now I can go back to this. I didn't have to go on site, didn't have to change ACLs on firewalls or tunnels or VLANs or ports or anything. I never had to set foot to enroll, to modify. We have this scenario actually on our actual certificate authority, our production certificate authority. We sign our certificates, and 364.5 days of the year, our CA is in scenario G, no traffic allowed. And then half a day a year, we turn it back to F with only me having access to it. I get in, I sign what I need to sign, I exit, we turn it back to G, and our CA is not disconnected because it doesn't have to, but it's still fully isolated from the rest of the world and any potential bad actor ever for 99% of the year. So think about your attack surface. Your attack surface essentially disappears without you losing productivity or operability within your network.
Matias, I just want to double down a little bit on, the real-time ability of the platform, because I think, we might be taking it slightly for granted here when you say, we push the policy and it's automatically updated. Like the networking OGs in the crowd here will understand the amount of work it actually takes to update a config on a perimeter firewall, which, typically involves a reboot, right? To reapply those configs on any piece of networking equipment. The automatic policy pushing of this platform and the way that it happens in real time, I think should be recognized as something that is amazing, really, right? Matias is changing routes and configs of devices and networks he doesn't control or own in almost real time to eliminate access. Like that's quite powerful.
Yeah, and this could be a 1, in this scenario, it's a 1 to 3, because when I push that, it affects these demo lab devices right there. It's still red. Look, it's still looking at red. If you have 1,000 devices, then it will apply to 1,000 devices at once. If you have 10,000 machines connected to these policies, that implication will broadcast to those 10,000 machines all at once. So you can very quickly isolate or change the behavior of 10,000 assets that you have deployed without talking to a single engineer or a single plant floor manager, or getting into a call with a single in-floor technician, or changing a single cable, or without asking anybody to help you with any part of the modification. If there's an if there's an emergency, if there's something you need really, really quickly being changed, then you can do that with less than 10 clicks and under a minute, and then you will be able to contain your infrastructure. We've seen too many cases in the past couple of years of infrastructure owners that, because they didn't have that power, they purposely started shutting down machines because they got breached and couldn't contain it. There's no need to name names, but I think we know, a couple of cases in the past 2 years of highly critical infrastructures that one asset was breached and it got out of control immediately. Sorry about the hearts. My Mac's doing weird things. It got out of control immediately, and their own IT team started shutting down stuff because they couldn't control it. With Byos, it is 5 clicks, under a minute, and then you've contained the breach. If anything, at best, you've contained the breach, and you were able to keep the spread count in the lowest possible number. That's also a very important benefit of being quick to action, 1 to thousands, and without the need to actually touch anything on the asset side.
Yeah, I think that's a good place to park it for now. Does anyone have any questions that come up that didn't get put in the chat? We can dig into a few other areas of the platform. Maybe activation is one we could talk about, Matias. But I'll leave it open for anyone who has questions for now. Cool. I think one of the big, one of the big sort of topical areas that people always ask is like, what does it take to deploy a Byos device, across an infrastructure, right? So we've built a very unique and quick and easy activation method for these devices, where you have sort of 2 components, right? You have the edge, and then you have the activator. An activator is a person in your organization who has been authorized to activate a device, okay? Matias, can you click on the activator section?
Yes.
And can you expand one of them? So essentially, activators, for all intents and purposes, is just someone's email, matias@byos.io, okay? An activator is put into an activation group, and then the activation group is assigned a policy group that the edge that activator activates gets put into. So in this case, Thomas@company.com. Whenever that person activates a BIOS edge, that edge gets put into the whatever policy group. Okay. Now what happens is, let's say Thomas has 50 BIOS edges delivered to him. He plugs them in, powers it on, connects that edge to the network, and then is prompted to type in his email. Thomas then types in his email, hits enter, and receives a TOTP, a time-based one-time password in his email, where they then take that activation code and plug it into the next prompt. And that BIOS the device then phones out over the internet. There's a bunch of validation checks that are done. Is this email approved as an activator? Is this edge in the fleet of edges for this customer? Does this meet the checks of that customer, based on whatever the policy is? If all of those different checks are met, then and only then will that edge receive all of the policy information and certificates needed to allow the communications of the assets to go out through the BIOS edge. And so no traffic is actually released through the edge until it's activated. And there's nothing private of a customer's information that is stored on an edge when it is shipped, right? And so you go from this state of 0 to 1 very quickly, where it's just, activate code, plug in the code, activated, and then you can deploy it how you want. We often then also get asked, okay, now that it's activated, what happens if a rogue actor gets their hands on this? Will they have access to my entire network? The answer there is no, they won't, because of the session authentication that's required to actually A, allow traffic, and B, access the edge itself. And so as the same mechanism that we use for activation, that activator types in their email, they get a 6-digit login token. They plug in that token, and then that gives them access both to the edge locally, and that allows the traffic to flow through the edge. That's also configurable inside of the policy, whether or not you want to allow packet forwarding through authentication, et cetera, et cetera. So, from all the way from getting an edge, activating it, accessing it locally, we've made the system very simple to use without, requiring memorization of local usernames and passwords. And it scales very seamlessly that way.
I want to add something to that, Ryan. I'm reading a comment here about device exposure. Whenever the BIOS edge, regardless of the form factor, connects to the network, it will connect to the network, and then it will get an update on policy and device posture. It's going to say, hey, this is the device, the BIOS edge, blah, blah, blah. Am I still allowed to connect? Am I still licensed? Because maybe the user, the device was deleted or blocked via overnight. And then I log in again at 8 a.m. The device will confirm that I still have access to connect to the network. Then that device is licensed, that everything is working properly, that the user is still allowed to use BIOS. But then the second question that the edge is going to ask the platform is, have there been any updates to my policy posture? Yes or no? If it's a yes, new policies are going to be pushed. The device is going to automatically apply them. And then and only then is going to allow the first packet out of the asset out, if it has been allowed. There's no interim exposure there's never exposure of the device, of your asset, and there's never exposure of traffic like a VPN does, like until you get connected, everything flows freely. That doesn't happen with BIOS. And that happens every time you connect an edge to the network. Now, where that is important, it's always important. Where that is extremely important in the case of the activator is that if I create a policy, let's say this policy, this activation group, whatever, The activation group, whatever, automatically goes to the policy called whatever. And Thomas@company.com is an activator on that policy. If I go to the policy, whatever, you'll see that it has no internet and inbound secure lobby, scenario F that I showed you before on demo lab, right? So all I got to do on the, let's say that I have 5,000 people, machines, etc., that are in a remote location overseas that need to access a resource that I have on my overlay right here that I can control. Call it a web server, file server, log server, FTP, web, whatever. They need to upload logs, get telemetry, whatever the use case is. They need to access that machine. That's the bottom line. I create the whatever policy. I add the activators that are actual employees or contractors or people that are working, that are going to be working on that remote location that are going to be activating those devices. And I put them in the whatever policy. Then I go to my network and I get, you know, demo lab needs access from the, hold on, policy, whatever. It's on the restricted. So restricted needs access to demo lab. So I go to the network and I go to demo lab, click on it, inbound access from which zones? Okay, add me restricted, please. I click restricted and I hit save. This is me as the HQ admin of this network. And now I have this new link. Restricted has access to demo lab. I create the activators, put them in the right policy, and establish access control between those policies and zones. And then I can shut down the console and go to bed. All they have to do on location, when they get the address, any of these, I can add activators right here, and I can upload 1,000 activators if I want. They're going to start activating devices. They're going to input that email address that they already own before deploying BIOS. And then all of that is going to flow naturally. When they do, and they activate those devices, the moment that those devices are activated, they're going to automatically fall into the right policy, meaning that they will have zero exposure to the network, to other assets, to other microsegments, to the internet, or even to the overlay. They will automatically be only allowed what they have been allowed by you previously and nothing else. So in under 5 minutes, those individuals with those machines in a remote location will be able to access and only access the very granular thing that they need to access and nothing else, without you having to be present there, without you having to share any information with them, preloading anything, software, pre-configuring anything at all. You create these three things, and then you shut down your browser tab. And that's it.
Cool. That was awesome. So I think we're almost at our time here. 3 minutes left. Wanted to say thanks for everyone who attended.